Okay, good morning. Today we're going to prove one of the angle sum identities, and you're going to work on the second one as your first problem. The reason why you guys learn about identities is that identities hold true for all angles. And there are also good ways to simplify a problem. So if you have a really complicated problem, sometimes you can substitute a section of it in for a different value and it becomes easier. So that's hence the reason why you need to know about them. There are hundreds of identities. We're only going to go over the more common ones. And one of the most common ones is this angle sum identity. What the angle sum identity does is if you say, for instance, you have a angle like 75, that is not on the unit circle, but you want to make your life easy because you want to have a couple angles that are on the unit circle. Well, 75 could be broken down into 45 and 30. Those are on the unit circle. However, sine of parentheses 45 plus 30 does not equal sine of 45 plus sine of 30. There is a whole identity that goes right here. And that is what we're going to prove this morning on this video. Let's go back over here. We're going to use geometry to show what the sine and cosine of A plus B is. So we have this triangle, this right triangle, it's in yellow. And then this one corner of the angle is angle A plus angle B. Just to make sure, so we're going to try and find, let's go put a little A right here. And let's talk about what this side length is. Cosine of A plus B, right? If we call the side length A, it's going to be A over 1. So A is going to equal the cosine of A plus B. So this side length right here. This length over here, let me get this focused a little better. This sine length right here is going to end up being the sine of A plus B. Now, what we want to find is what the side length is with just A's and B's by themselves, not being added together. So what's all going to equal? Keep in mind, this triangle is being represented again by this triangle, and that the sine of our right triangle right here is going to be this length. So if we can figure out what this length is, then we know what this is going to be equal to. Now we're going to do that by looking at other triangles. One of them is this one right here. If we take this triangle and pull it out, we will notice that angle B, the cosine of angle B, the side length right here is going to be the cosine of B. And that means this little piece right here is the sine of angle B. All right, so keep that in mind. In fact, I'm going to go put it over here. The side length right here is the sine of angle B. All right, we got that. Let's go ahead and take a look at this triangle right here, which is being represented down here by this triangle. We know its hypotenuse is the cosine of B. Hey, let's go ahead and figure out what this side length is going to be, which is going to be this length and this length. Let's call it X, and let's call this Y. All right, so let's think about this. Cosine, let's say cosine of A is going to equal this side length, which is X, over cosine of B. So X is going to equal cosine of A times cosine of B. Okay, hey, we can do the same thing for y. We could say the sine of a is going to equal y over the cosine of b. So y is going to equal sine of a cosine of b. Okay, so y is this length right here. That also is representing this length. So this is y, which equals sine of a cosine of b. All right, so we got this side length, and we've got this whole length. Okay, hey, let's go ahead and find out what this length is right here. If we find out this length, then we know that, which is this whole length here is going to be the same as this whole length here, then we know what the sine of a plus b is. Okay, I'm going to go ahead and tell you this angle right here is the same as a. And I will leave it up to you to figure out why. If we know this is the same as angle A, then this is going to be the same as angle B. And we can kind of go do the same thing we've just done. This is going to be y prime, and this is going to be x prime. Okay, so the sine of A, let me move it down, for this little triangle right here is going to be x prime over sine B. So this little area right here, length, is going to be sine of A and sine of B. Well, we do the same thing here. We take the cosine of A is going to equal y prime over sine of B. We end up with y prime equals cosine of A, oops, I'm running out of space, times sine of B. Okay. Hey, now we know the whole entire length of this side of the triangle. Right here. So if we did the sine of A plus B, it's going to equal this length over 1. Well, what do you know? You just add them together. So the sine of A plus B is going to equal add this piece here, the sine of A times the cosine of B plus, in my room, cosine of A times the sine of B. Hey, that's one of your angle sum identities right there. You know the sum of two angles, you can break it into these pieces, find the sine and cosine of each one individually, and all that will equal that. That is one of them. Okay, well, that's lovely. Now what are we going to do about the cosine of A plus B? Well, the cosine of A plus B is going to be this length. Well, that's this length, which we determined down here was cosine of A times cosine B, minus this little piece, which we figured from up here, this little triangle, was sine of A times sine of B. So let's go ahead and write that out. Go back over here. Cosine of A plus B is going to equal cosine of A times cosine of B minus sine of A, sine of B. Right? There is your other angle sum identity. Okay, those are the two formulas right there. I'll underline them. This is problem 107. I just walked you through it. Again, sometimes you have to stare at these triangles a little bit to say, okay, now which piece did I do first and which came second? It's a fun proof. And it allows you to do that problem, what's the sine of 75? You break it into sine of 30 plus the sine of 45 and figure out what those are. I will do an example in the second video of how to apply these guys. For your next problem, they're going to ask you to do the difference identities. And all you got to keep in mind with the difference identities is that it's the same as adding, but you're adding a negative. And keep this fact in mind, that the sine of -1, negative x, is minus the sine of x. And that the cosine of minus x is the cosine of x. That's your even, odd and even, that's odd, that's even functions. Keep those in mind. Those will help you great in the next problem in 108. All right, good luck. I will do an example in the next video.